Hello, welcome back to Cracking the Cryptic, and congratulations to England's Lionesses, their women's football team last night qualifying for the Euros final. But today we are going to be looking at a new constructor's puzzle, and this one comes with letters. It's called 18 Letters. I don't think I'm aware of the name Dante Hydemark, which is a great name, not just because it incorporates my own, but it's certainly a new constructor to me. Now, don't forget before you do this that you can, of course, check in with our Patreon website, our Patreon channel, what's it called? Our Patreon page, and join us on Patreon. Our Discord channel, the various apps and merchandise, and Sven's SUDOKU PAD. Now, I'm not 100% sure how this works in the SUDOKU PAD and how it will come out on phones. So apologies if you have to play it on a computer. Not certain about that. I have added these final two columns, and I'll explain the rules now and why those columns are there. And also how to use the letters in our software. So the rules are these. Normal Sudoku rules apply, and that is to the 9x9 grid. That's what we're trying to fill. In cages, digits must sum to the small clue in the top left corner of the cage, and digits can't repeat within a cage. Each of the 18 letters used in the grid represents one of the digits 1 to 9, with exactly 2 letters corresponding to each digit. So each digit has 2 letters that can represent it. No letter represents 0, and the 2 columns on the right are just for notating any discovered equivalences. One of which is given to us. We know that H equals 1. So, fascinating idea for a puzzle. I mean, we've certainly done puzzles before with letter number equivalences, but possibly not with 18 of them. Now, what I want to mention is that if you click the cogwheel in the settings, you can enable the letter tool. That's the second thing down, which allows you to write letters in the grid. And you can actually change the keypad to be letters using what then comes up as a 9-A key, if you want. Or you can just type letters into, I believe you can type, oh, maybe you have to go over to the, you have to use the 9-A keypad key to then be able to type the letters in. But I think it's still a fun idea, and I want to give it a go, even if the software makes it not simple, but we shall see how we get on. Looking forward to giving this a try. Do give it a go yourself on a computer if necessary. I am going to start now. Let's get cracking. Well, we've been given, as I said, H equals 1, and there is an H in the grid, and it's there, so that's a 1. Now, in this cage, 1 plus P equals C. P and C are there in the middle box. Wow, what the heck do we do to make any progress here? Right, there's a lot of 2-digit numbers for cages that can't be that big. So we know, I think, that the maximum value of a cage in this sort of Sudoku is 45, which is the sum of the numbers from 1 to 9. That's our big secret. It's not much of a secret. Yeah, look, this is... Okay, I was getting totally confused. We've got 6 2-digit numbers listed. We've got NE, LG, RO, JD, BL, and KH. Now, at first I was going, well, this is impossible, but I'd forgotten that it's 2 letters per digit. So JD has to be no more than 24. Numbers can't repeat in a cage, and it's only 3 cells big. So J has to be 1 or 2. Can I... I can put J in the corners there. NE and LG, oh look, and RO and BL, they're all 5-cell cages, so none of them can be more than Yeah, none of them can be more than 35. 98765 is the maximum. So the tens digits are N, L, R, and B, and they all have to be within 1, 2, and 3, don't they? They do. N, L, R, and... oh, sorry. Oh, my goodness. Okay, now... I don't know what I did there. Right. N, L, R, and B. Right. So... N, L, R, and B. And that means this is a set of 5. So let's get rid of that and write... sorry, I'm just trying to be careful. B, J, L, N, and R are those digits. I think they have to be the 1, 2, 3, the 6 additions of the 1, 2, 3 digits. Yeah, I'm confident about that. And so K is not 1, 2, or 3. And this is a 40-something cage. Well, it's got to be 41 or 42 because it can't be 40. We're not using 0. And if it was 43, you couldn't make up the total of these two digits. So K is a 4. Well, I'll write that in here as K. There we go. And H we know is a 1, of course, so it's a 41 cage. These two add up to 4. They are 3 and 1, and it must be so. So there we go, digits in the grid as well. Now I noticed this. E is a cage that just contains an A. So A and E are the same digit. Now they can't be 1, 2, 3, or 4. So A and E are a pair somewhere along here. I might as well write 5, 6, 7, 8, or 9 in there. It's a bit point. Actually, no, I'm not going to because it obscures the A unnecessarily. I'm just going to remember that. Right, P. No, hang on. JD. I was thinking that must be a 20-something, but it couldn't. It could easily be less. Okay, so what do we know? I think we still have to keep focusing on these tens digits. But the trouble is, they're all potentially... it could be any of these numbers. 2 of them are 3s, so 2 of these 5-cell cages are 31, 2, 3... not 33, 31, 2, 4, or 5. Ah, okay, what are the units digits? So, BL is the one that is below 35. Oh, that's interesting. Okay, so whichever of... BL could be a 31 or 2, because L is 1, 2, or 3. But RO... LG and NE have to be at least, if they contain a 3 as a tens digit, they have to be at least 34. I don't know that that's helpful yet. Irritating. No, I don't really understand what to do with that information. I suppose it means that one of G, O, or E is a 4 or 5, but that doesn't seem powerful. Or do I know more than I realise I know? I suppose this... how could these two be... oh, hang on, let's have a look at these other cages. I, F, and Q. I is 3 digits. F and Q are 2-digit cages, like C. Oh, Q is at least 2 plus 4. So Q has to be at least 6. I suppose none of the others, we know they're not 1, 2, or 3 because that is a limited... ah! JD here. D can't be 1, 2, or 3. Oh, that's quite interesting now. So this is either... Somewhere between 14 and 19, or it could just be 24, couldn't it? Oh, look, J is not 1 in column 2. Oh, right, J has to be 2. Ah, okay. Sorry, I'm hitting the wrong buttons. I'm really hitting the wrong buttons. Now, let's try hitting J there. There we go. J is a 2, because here it says it can't be a 1, and this says it couldn't be more. So JD is 24 then. That's a D. Yeah, we're away here. So this is a 9, 8, 7 set. P is 7, 8, or 9. Oh, and that's P there. So it's 7 or 8. It's not 9. And C is 8 or 9, and that's there. C is 8 or 9. Let's do that like that. Interesting. Oh, J is 2 now, so we can just fill in a 2 there. And now we're stuck again. This pair that makes Q can't be more than 2, 7, making 9. That's not very interesting. Oh, hang on. Look at the shapes of RO and BL. That's interesting. The interesting thing about the shapes of RO and BL here is they all see the central digit, which is 8 or 9. So what is the maximum that RO and BL can be now? Because they can't, imagine this was a 9 in the middle, then the most they could be is 8, 7, 6, 5, 4, which adds up to 30. And which is below, which would stop R or B being a 3. And if you stop R and B being a 3, L and N are 3s. And then these cages are at least 34 and 35. No, not 34. They're both... that's impossible. Because we've ruled out both 4s now, since D became a 4, we're only left playing around with 5, 6, 7, 8, 9 for things like G and E. Yes. Right, so the case I was just postulating was that this was a 9 in the centre. Then RO and BL can't be more than 30 because they can't have a 9 in or a repeat digit. So they would have to be beginning with a 1 in one case and a 2 in the other. That would leave N and L. Is that right? Yes, that is right. That would leave N and L to both be the 3s, and both of these cages would have to be at least 35. But if they were both 35, that would be 9, 8, 7, 6, 5. And this would have to be 9, 8, 7, 6, 5. And that would cause all kinds of clash across the top row. So this is not a 9. This is an 8. And now one of these is going to have to add up. I mean, it's still the same deal. You can't leave these to both be 35. So one of these is going to have to add up to a 30-something number. And the maximum they can be is 9, 7, 6, 5, 4, which adds up to 31. That's the maximum. So one of them is 31. It's not RO because O can't be a 1. So it is BL. BL adds up to 31 is 9, 7, 6, 5, 4. L is a 1. Yeah. B is a 3. We can take B and L out of here, I think. They are N and R. Yeah, that's right. This is 31. Okay, bingo. Oh, what have I written there? 3 and 1. I should have written B. Oh, what's going on here? Right, B and L there. That's it. This cage is 31. Okay, that's cool. Now, RO. Now, can this also be 31? And I don't think it can because we'd have too many 9, 7, 6, 5, 4s. So R can't be a 3. So R is a 2. N is a 3. We've got lots of equivalences done suddenly. This RO adds up to 20, somewhere between 25 and 29. Oh, that 8 has made this a 7. That's P. P is a 7. C is an 8. That has to be right. Yeah, just checking my logic to make sure I'm comfortable. Wow. A and E, which are the same, are now either 5, 6 or 9. Oh, they can't be 9 because there's an 8, 9 pair looking at them. So A and E are either 5 or 6. 7 can't be in any of those cells. So, oh, and it can't be in that cell either. So we've placed the 7 in this BL cage. There. Oh, and all of those 4, 5, 6, 9, and 8, and 7, and 2 are all looking at this cell. So that's 1 or 3. And this, I don't know that that's going to help yet. This is in the 20-something cage. Ah, it is interesting, actually. This could be a 9. Actually, there could be a 9 here as well. But, oh, and that could be a 7. Ah, okay. I was thinking this was getting quite limited, but I don't think it is getting too limited yet. Close, though. Right, NE is now... Ah, this is 30-something above 4. It's got to be 35. So A and E are 5s. I should have spotted that. Okay, I have spotted it now. A and E. That's a 35. That's 9, 8, 7, 6, 5. This one can't be 8. Now, LG here is 1 followed by 6, 7, 8, or 16, 17, 18, or 19. Oh, this is a 1, 2, 3, 4 quad in the top row. That one can't be 1 or 3. Can't be as little as 15, can it? So I don't think I've got a good restriction going on G yet, which is also there. Wow, okay, this is intriguing, this puzzle. Let's make one of those a 7. Actually only got 6 equivalences left to fill. RO is 20-something. I, 6, 7, 8 or 9, it could still be a 6 even. F here, don't know anything about that. Q has to be at least a 6. It's no good restricting Q and I to be at least 6, because I know Q and I are at least 6 from down here. M also is at least 6. It's very strange to me still to think that we're going to get enough data to fill this grid. Okay, if this was 1, 2, 3, they would add up to 6. The maximum you could have in the rest of the cage is a 7 and a 9, making 22. And that's not enough. This cage has to add up to at least 26 because of the value of O. So this is not a 1, 2, 3 triple. In fact, 1, 2, and 3, 2 of those digits are in here. The other one's there in the box. So the maximum this could be is 329, I reckon. Well, 3 and 2 are in this cage. Okay, next question I'm going to ask is there a 9 in it? Because if there isn't, there's no 8 in the cage. It could have a 7 here, but if there's no 9 in it, it's got a 7 at a max. It's got 7 there, 3 and 2, say, here and here. And then you could have 2 6s. That can't be enough. 14, 21. Oh, it is. 24, 26. That's exactly enough. That's how it would have to be done. You'd have to have 6, 6, 7, 3, 2, if there's no 9 in it. But if there is a 9 in it, oh, no, all it means is that can't be a 9. Oh, it's close, this now. Now, unfortunately, the fact that there could be a 9 in it releases all those degrees of freedom. And it could be 9, 3, 2, 6. What's that? 15, 20. Oh, it's still not very much. Oh, it's getting interesting. Hang on, hang on, hang on, hang on. I think it is about the size of this cage at this point. That's really odd. So let's start with if this wasn't a 7, which is quite interesting because you can still have a 9 in the cage somewhere. But then none of the other digits could be 8 or 7 if that's not a 7. So then the most you could have is 9, 6, 5, and you have to have 2 of 3 and 2. Or 2 of 3, 2, 1, sorry. And that would only be 25. I think I've just proved this is a 7, which is really weird. If that's not a 7, the most you can have in the cage is 9, 6, 5, 3, 2. Which is 25, but it has to be at least 26. So that is a 7. Wow, this is quite constrained. So surely there's got to be a 9 in it now. If you didn't have a 9, it would be 7, 6, 5, 3, 2, which is only 23. There is a 9 in the cage somewhere. And that does mean this cell, which sees all of those digits, can't be a 9. So does there have to be a 6 in it? If you didn't have a 6, you'd have 7, 9, 5, 3, 2. I might have done that sum before. That is 26. So there doesn't have to be a 6, but there does have to be a 6 or a 5. So it's made up of 9, 6 or 5, and 3, 2 or 3, 1. There's no 4 in it, so those aren't 4s. There is a 4 in one of those cells, and there isn't a 4 there, which is a minute deduction. 7, 9, 5, 3, 2. So that's possible. Then 6 would also be here. Okay, these cells that I've highlighted must contain either 9 and 6 or 9 and 5. There's no other way to do it. Yeah, there's no other way to get up to at least 26. In fact, what's the most now? 7, 9, 6, 3, 2. That is the most it could be, which is 27. So O is 6 or 7. Interesting. Yeah, that is interesting. O is 6 or 7. But if, yeah, these cells contain either a 9 and a 6 or a 9 and a 5. Now that's going to have an impact here, isn't it? No, not necessarily. It's going to, as I said earlier, it's going to make one of them have a 4, but I don't think it defines anything else quite. Might be missing something. Oh, E, we know that's a 5. I haven't written that in yet. 5 there. So there's no 5 there, and there is a 5 in these two cells, where there's no 7 now. There must be a 7 in these two. Oh, where's the second? Well, those can't have an 8 or 9. No, it's not that interesting. Sorry, I was just observing that those can't have an 8 or a 9 in. Well, in fact, that does make that 2, 4, or 6. This is getting quite small. Not small enough to help, actually. There's a 7 down there somewhere. There's a 1 in one of those two. haven't thought to do a bit of regular Sudoku for a while. 7 is in one of those two cells actually, in box 9, so that's not a 7, and that is in the LG cage. Right, so the minimum this could be is 2, 4, 5 here is 11, plus 7 is 18, plus 1 is 19. That's it, because it does begin with a 1. That has to be. So it's a 5, 2, 4. Good grief. 5, 2, 4. That's a 1. So they're not. This is a 6, 8, 9 triple down the side. That's not an 8. G is a 9. We learnt that. In the cage. Now, have I missed any letter equivalences? We've got F still to resolve there, and Q. We've got 5 more, F and Q. We haven't done O for definite, that's 3 of them. We haven't done I, that's 4. And M over here. Is that the only place M appears? I think it is. So I might still be scratching around with this cage trying to work out what's going on. Oh, that's a 2, 4 pair looking at that cell. Well, that makes it a 3. 7 these. This is a naked 6. It sees a 5, 8, 9 group in the row as well as all of those in the box. So these are from 5, 8, 9 and definitely include a 5. 5, 8, 9 triple. Does that 6 do anything? Not obviously. 1, oh, that's 3 or 4. It's funny how some of these combinations really restrict individual cells. I think I'm going to have to go back to thinking about this annoying cage, which I'm sure adds up to 26, although it could theoretically be 27. It's got a 9 in, we know that. It's got a 6 or a 5 in it. Oh, the only place 5 could be now is there. If that was a 5, oh, look how this is impossible. That's lovely. If that was a 5, I'm just observing that the 5s there have ruled out 5 from those cells. If that was a 5, the 5 in the BL cage would be here. The 5 in column 6 would be here, and that would rule out 5 in box 3 at all. That's beautiful. Okay, so this is not a 5. There isn't a 5 in this cage, so there must be a 6 in it now. This can't be a 6 because it sees all those cells. The trouble is, I think there has to be a 3 in this cage as well. If it was 7, 9, 6, 2, 1, that would only be 25. Yes, there's definitely a 3 in the cage somewhere. But then either a 2 or a 1 to go with it. Oh, we're nearly there now. Come on, keep pressing ahead. This can't be 2, 7. So if it's 6, it's 2, 4. If it's 7, it's 2, 5. If it's 8, it's 2, 6. If it's 9, it's 4, 5. In which case, that digit would be there, and that digit would be in one of those. None of these could have a 4 and a 5. Ah, it's so close to being impossible. 7, 3, 6, 9, 2. Ooh, if this had a 2 in it, the 2 would have to be there, which would put a 2 in the F cage. Right on the cusp here, come on. What about this? I don't know, I mean, I only know high numbers that it doesn't have in it, like 7 and 5, and it's difficult to get the other high numbers in. On the other hand, 1 and 2 one of them can be there in this box, but the other one has to be in one of those two cells. No, it's not. Actually, this cage can't have 7, 8 or 9 in. That might be worth thinking about. So 6, 7, 8, 9 in box 1. 3 of them are there. The other one can't be. Oh, 6 could be. Ah. Now, 8, can that possibly be here? If F was 9 and if this was an 8-1 pair, does just about work. Oh, hang on, there's no... Oh no, I was going to say there's no 3 in that group. That's not true. I mean, it might be true, but it's not provably true. It's not demonstrably true. There is a 3 in that set. 2 somewhere in those cells. Ah, oh, really close here. Come on, keep thinking it through. Only Q, F and I have to include. Well, one of them has to be a 7. It doesn't do anything in any case, actually. Although if there's a 1 in one of those two cells, that's slightly interesting. Can it be here? This has to add up to 6 or more. It can't be 1, 5 or 1, 7 or 1, 6 because they're both looking at that. Could it really be 1, 8? That's the only way the 1 could be in it. If this was 1, 8, then F would be 9. Does just hold together. Oh, that's close. That's close to being a really smart way of looking at it, but it doesn't quite work. Now, 1 is not in those cells because it's in one of those two. So, can it really be there? This could be 9, 6, 3, 1 if this adds up to 26, couldn't it? Oh, so frustrating. Oh, G. G is 9. I got that ages ago and I haven't written the 9 in up here. Honestly, pay attention. That's actually very helpful. That's an 8, 7, 6 triple. So this is a 5, 9 pair. That means this is 8. That means this is 9. That means this is a 5, 8 pair. There's no 5 in this cage. I'm not sure if that does anything. 6, 7, 8, 5, 9. That is 3 or 4 because it's subject to the same 1 and 2. So we've got a 1, 2 pair in the box. Now, we haven't placed 6 in this row. 5, 9, 7, 8. That can't be 7. 8's now down in one of those cells along with 7. Is it about I now? 7, 5, 8, 9. It's made up of low digits, obviously. Still, this could be 1, 8. Oh, come on. Where does 1 go? 1, 7, 2, 3, 4. So the rest in this column are 5, 6, 8, or 9. And the central digit can't. The central digit is an 8, so that can't be. Now, 5, 6, or 9 there, but 9 and 6 have to be in this cage, both of them. So I don't think this can be... Oh, so one of them is in one of these two cells, because they can't both be there, and that makes this a virtual 5, 6, 9 triple, looking at that cell, which becomes a 4. And if only one of these can be 5, 6 or 9, that one is 6 or 9. Yeah. 5, 6, 9, triple, 8, 4, 7. That is 2 or 3, and that is 1 or 3. They have to be low numbers. The other of the low numbers is here. Oh, come on. Does it have to be a 3? That would be really helpful. No. Okay, but that felt like a dash of progress. Ah, this can't be 2, 3, 4 because of that cell. So there is a 1 in the cage. I don't know, that doesn't actually help. It means that can't be a 1. Ah, that is interesting. These two cells can't be a 1 either because of that and that. So the only one possible in column 6 is here and not there. That probably doesn't do anything. We know that there is a 1 in this cage though. And it can't be 1, 3, 4 adding up to 8. And it can't be 1, 2, 5 adding up to 8. It can't be 1, 2, 5 because there's a 5 there. And it can't be 1, 3, 4 because there's a 3 or 4 there. So it doesn't add up to 8, given that we know it has a 1 in it. So I is not 8. Could it be 7? If that was 1, 2, 4. Can it be 9? Can we rule a 6 out of this cage? Because then we could fill in a 6 here. Oh, I've got a 5, 6, 9 triple there. This is low. This is the other one from 5, 6 or 9. It is 6 or 9 because it can't be 5. That's a 6, 9 pair. That gives us a 5 here. That takes 5 out of a couple of cells. That's a 6, 9 pair, and they see all of these. Both of them are a pair. So these can't be 6, 9, 7, 5 or 2. So they must be from 1, 3, 4 or 8. So one of 6 or 9 is here because of that pair acting on those cells. One of 6 or 9 is there, forming a pair with that, and this becomes 8. That's clever. There's a 6 or 9 there and a 6 or 9 there. 7, 5, 8. This cage is made up of 1, 2, 3 or 4. Only those digits. It can't have a 1 in it because F has to be at least 6. Haha. So that's not a 1. That's a 1. I actually thought I'd gone wrong for a moment there, but that's now a 3. This isn't a 3, obviously. These aren't 3s or 1s. That's a 4, 8 pair. This is 9. That's 6. This is 9. Still don't know whether O is a 6 or a 7. That's a 6 though. That's a 9. 2, 3, 4. Now, F could be 7 or 6, but there has to be a 4 in this. Yeah, that's okay. So F is 7 or 6 as well. Oh, come on. This one. Oh, 4 is looking up at that cell. That's good. So 2, 4, 2. This can't be 2 anymore. 2, 5, 9, 2, 8, 7, 4, 1, 3. This is 5, 6, 1. It can't be 9 in this cage. I think this is going to have to be a 2 now. No, it could be a 4. Q can still be 7, 8, or 9. Bother. 3, 9, 1, 7. That's not a 3. This is 4, 2 or 4, 3. 8 is looking at that. So we've got another 5, 6, 9 triple. I have a feeling I'm just missing something now, but that's okay. We've made good progress. Once I spot it, M is not a 9. M is 6 or 8. So annoying that I can't rule these out. The 9 is I or Q. If it's Q, that's a 4, 5. If it's 9, I suspect that's a 1, 2, 6. Although could be 1, 3, 5. No, it couldn't. It would be 1, 2, 6. In fact, what can this be? 1, 2, 6, 1, 2, 4, or 1, 2, 3. That's all it can be, because it can't have a 5 and it can't have a 3, 4 pair. So it's always got a 2, and that's there. That's nice. Okay. That's going to fix my triple across the middle. O has just become a 6, I think that is. Yeah. So we'll put that in here. O. That doesn't really, I thought that was going to resolve all sorts of things. Absolute tripe. Now, this is either 216, 214, or 213. And that doesn't tell me anything there. But this has become a 6. That makes this an 8 and 9 at the bottom of the grid. These are a 6, 7 pair. This is a 1, 7 pair that can be filled in. Oh, I think I can just do this now. They don't have a 6, so the 6 in the cage is there. That needs a 6 here. So I is not 9. And therefore, Q is the only thing left that can be 9. Yes, it is. This notation was worth doing. That's a Q. Q is 9. That is a 4, 5 pair as a result. And that might actually get us home. This is a 3 to finish the column. This is a 9, 5 pair that have been resolved. 1 in the box is there. That's part of a 3, 4 pair. Oh, that's in the I cage, so that will get resolved to either make 6 or 7. I is in one of those. Actually, let's tidy up the pencil marking. We don't want O in there anymore. I is now in there. So they're an FI pair, and that's not M, and M must be here. That must be right. I'm confident about that. M is an 8. Where does M go? Here. That's an 8. That fixes 4 and 8. 3 in the column has to be there. 7 in the column has to be not in the bottom box. 2, 5 pair. 4, 6 pair that are resolved. That can't be 8. Wow, here we go. This is a 4 now, and that's a 3, and F is 7. There we go. So I is 6 after all. There we go. That's all the letters. I is 6, so that becomes a 3. That fixes the deadly pattern up here. 3 and 4. That's a 2. What have we got? Oh, this can be filled in. That's a 2, not a 0. 9 in the column is there. This is part of a 5, 8 pair with this. No, a 7, 8 pair, which I can do. Yeah, that's okay. I thought I'd got something wrong. Don't think so. 5, 2 there. 5 and 4, 7 and 2, 6 and 8, and 8, 5 pair to finish off that. It's a very interesting puzzle. Now, it's not going to say this is correct. And even if I click the tick, it's not going to love it, I don't think. No. But don't worry. The puzzle doesn't include its solution, but that's what the solution should be. It's a very clever, very detailed puzzle by Dante Heidmark. And most enjoyable for all of that. So, as always, thank you so much for watching us here on the channel, and hope to see you soon. Bye for now.